thank you very much, Diane. Yeah, my name is Matthias Luebken, and today I'd like to talk a little bit of how our experience of running our operator, of running Kubernetes workloads, and what we see from our customers of the challenges they have running these. Just a few words about myself. I'm the PM for Kubernetes and infrastructure at Instana. Got some experience in software development all over the place. I've actually been with Red Hat, done some interesting stuff over there. And now with Instana, we are focusing on helping developers and DevOps teams to kind of manage all this crazy things that we're seeing. And operators help a lot. I hope this talk helps a little bit, and yeah, some of the experiences that we had. All right. So basically, one talk in the slide, right? This is the agenda. This is the talk. So what I would like to talk about today is basically give an understanding of how of what to look for if you're running an application in Kubernetes. And we kind of like separated the different aspects, the different perspectives, and came up with these three perspectives, basic perspective, different views on this. And that's what I would like to share today, and also give you very tangible ways of doing this. The slides, the contents have a lot of further links to deep dive on how to get it going for yourself. So I hope there's a lot of things to take away. All right. So this was actually something that brought up in May, but I love that. I love the phrasing of it. As Kubernetes is very good at solving the problem it induces in your environment, right? So Kubernetes and OpenShift are awesome platforms. Are awesome platform for managing distributed setups. But at the same time, it also introduces a lot of the complexity that we might or might have not been exposed to initially. And I think this is a real challenge, right? It's yes, we're techies and we want to get this all solved, but it's not always simple, right? There's challenges for developers, there's challenges for DevOps, and I think there's a lot of things that we can do better. And hopefully we're doing part of it today. So if we take a step back, or if we look at what a Kubernetes application actually introduces, it's actually quite a few new attributes that make these things really challenging. The first of all, it's we've talked about microservices-based applications before, but to be honest, that hasn't been the scale as I've seen before with Kubernetes. And with Kubernetes, there's a decent application suddenly consists of hundreds to thousands of microservices, very different. And you can talk about pros and cons of microservices, but the matter of the fact is Kubernetes allows us and gives a lot of means to doing so. So people are taking advantage of it, but they also need to manage these. Right? The change also increases dramatically with developers. OpenShift provides a great platform for continuous deployment. And the increased change of these is just tremendous. And pods come and go, right? So you've got these autoscalers, you've got rolling deployments, and everything is getting ephemeral, right? So also something that at least for me, but also what I'm seeing from customers is something that they've not been really used to it. And containers are awesome, right? We've got now the whole fleet of suddenly just packing everything in a container, putting the runtime on it, and then just pick the technology you want. Everything is polyglot now, but who manages this, right? Who's taking care of this? So when you are then looking of what does that mean? What are the problems? What are the challenges that you face? That these are some of them that I hear most. Is if they are using Instana or any other tool of looking at of what the Kubernetes applications are doing is like, okay, so first of all, what is actually affected? Like Like I'm building my application, it has a problem, what are actually affected? And what metrics do I need to look at? Like, well, what is the CPU utilization? What are the request rates? And where do I start looking at? What do they actually, all these metrics actually mean, right? Okay, now I've got a list, but how do these work together, right? Now I've got a couple. What else do I need to look at? And what is the root cause to all this problem? And again, right, this is about, developers, DevOps that are now, working with this new environment. For them, new, right? Maybe for some of the industries, like, been working with this for quite a while, but this is like, being new, right? It's new for them. And operators put another level on it, right? They do codify a lot of these things, but they put another level on this, and stitching these things together might have their own means of sharing that distributed load and putting their own custom resource definitions. And again, like, which metrics do I look at? What do these mean, right? So another layer of challenges in managing the Kubernetes application. All right, let's look at it. Let's look at it as an example that just to make it a little bit more tangible to discuss what we were talking about. So this is a very I don't know if it's a very simple example, but probably not too unrealistic example. Let's say we're building an Elasticsearch search application, right? And throwing out using Elasticsearch, the common tool for that. So running this in Kubernetes, obviously means that we have a deployment in a namespace, then the Elasticsearch itself is written in JVM, so that JVM is running in a container on a pod. Most likely we're running this on a Linux host, right, which is itself a Kubernetes node with its own properties. And all this thing is running in a Kubernetes cluster and some availability, right? So the question is like, what do I need to know? What happens? And I guess, if you're looking at a problem, right, then these all surface, right? So this is like the simple example or the simple stack. The more realistic example is that we're actually talking about a cluster, right? So the Elasticsearch is not a single node, but rather a cluster. And each of these, each of these clusters is obviously mentioned in a couple of nodes. And we might have a Spring Boot application or another Java application, most likely with a similar stack. So let's look at a problem that could happen, right? So let's start with the lower right-hand corner, the first one. Let's say that the node has an I/O problem, right? And that particular shard in the Elasticsearch cluster, is getting something to look out for. Then, maybe the thread pool itself on the JVM on the Elasticsearch node has a problem and is a warning sign, right? So I'm circling the yellow circles are kind of warnings to your system. And then another Elasticsearch node needs to take over, and there the thread pool is so overloaded that it actually goes beyond a certain threshold, and that requests are queued that much that it can't fulfill the service that it was supposed to. So actually the overall cluster gets the throughput is decreasing, and the performance of my service application is also decreasing. So I think the message I want to bring across is this is, I wouldn't say too complicated, too far off application, a rather simple application. But you can also see that specific problems could be somewhere, anywhere in this setup. And I would like to give a little bit order into this and give a little bit guidance on where to start and how to look for. Right. This is a little example from our tool. So Instana is a monitoring observability tool. We do all sorts of sources of what we gather, and we've got this dynamic graph that hooks up everything. And this is actually just a visualization. This is a fun project of seeing the Death Star of all these components hooked up. Quite fun actually. The live version is even funner because it's dynamic and you can see things moving. All right, so how do we get started? Let's look at a suggestion of how to reason about all. So I guess anyone looking at any ways of managing, monitoring any modern application, everyone kind of agrees that the first one to reason about are services. Services to what the user or the internal user or a dependency within the microservice landscape needs to provide is a logical abstraction that we're looking at, and we're going to talk about it. But we can't stop there, as I tried to go earlier. So I think the second one, and that's obvious for this one, for this audience, hopefully, is the Kubernetes environment, right? The Kubernetes environment, the OpenShift environment, to understand of what's happening there, to get an overview of the namespaces, the pods, the deployments, other workloads, etc. Now, the third one, and let's see what we can get out of the conversation here, is what I would like to argue for is that the infra level is not going away. We try to build up abstractions, but whenever I'm seeing, looking into some examples, there is always something where you start looking up how a particular container is behaving on a particular host. So infrastructure, as I showed earlier with the I/O example, is still something that we need to look into. But as the talk, right? Context. The context is king. You need to understand on how all these things relate to each other. So that's the fourth dimension or perspective I'm going to talk about. So in one slide again, right? I think if you reason about of how do we manage Kubernetes applications, then I would try to start looking at these three core perspectives: the logical as service application, the Kubernetes layer in itself, and the infrastructure layer, and how all these things tie together. It's interesting when I started talking about these, that you could abstract these to specific roles, right? And I think certain roles are naturally bound to one or the other. So you can think about the services on being for the developer, the Kubernetes side of things on the DevOps side, and the infrastructure on the ops side. So I just put them here. But I also think that it's, the nice thing about DevOps is that we're not building up walls, right? So we don't want to cut off and then say, I don't care about the rest. Just give me a host and I'm done with it. We want to combine these. So I think it's also important to share this perspective, share these views, share these metrics, share dashboards between the different organizations. And yeah, I'm looking forward to what you guys think. But that's our perspective. Now, just a word. This is one view of this, right? And we kind of brought that to Instana, but there's obviously lots of all other perspectives, like end user monitoring, business custom metrics, synthetic modeling, networking, security, yada yada yada. I've actually had the argument when I was preparing the talk with a colleague of mine that something else is such more and more important than the three perspectives I'm talking about here. So it's one view, right? And if you think others are more important, happy again to reason and talk about it. But I think these are generally applicable. All right, so we've got these three perspectives. So what should I look at? How should I look at these? And then last but not least, let's put them in context. All right, let's start with the service again. What am I looking for? So the definition for services for me is something that has some logical context to it, right? So it's implementation and infrastructure independent, and we care about what the service provides to that user, right? We've also got these SLI, SLOs, which will work perfectly with it. The important piece is that it's a logical unit that serves a user a service. Now, the important piece is that we're looking at it as an implementation independent definition here, because technology specific KPIs can be misleading, right? And maybe you want to exchange the service with a different technology. So there's so many things that you can consider about the technology. So let's look at the logical in itself, especially in Kubernetes, as I briefly mentioned, with a polyglot environment. There's so many things. So let's take the logical view on this extractor. We don't have to overdo it, but that's like the. So if we're then looking of what to observe, what are we looking into? The first question that you need to answer for yourself, for your team, is of the granularity of our service. We're supporting very heterogeneous environments, and I guess in Kubernetes there's already a structure to what a service is, but it doesn't have to be, right? You're not bound, and I think you shouldn't bound yourself to a Kubernetes service in itself, but think again service as a logical unit for yourself. And if you have an old web server, then you might split different endpoints. You might have different granularities of what works for you. And in Instana, we have the default is something that is named and a certain type, like HTTP database and the like. But again, that's up to you on the granularity of the service. The other part is that need to consider is some sort of higher level assemblies. Given the operator, right? Operator is a good means of stitching these things together. There's also the application CRD or Helm, but it doesn't have to be on the Kubernetes side of things. You can also think about it differently. Of maybe some other backend unit is also belonging to that logical assembly. And I'm making this term very, very loosely. We're calling these application perspectives. But whatever works for you to combine a couple of logical services together to then serve of what's needed. There's a pretty good understanding right now of what to observe. The four golden signals by the Google SRE book have introduced these latency, traffic error saturation. Tom Wilkie from Weaveworks Grafana has introduced the RED method, which resonates a little bit more with me, because it takes out the saturation, which is a technology specific, often a very technology specific component. That said, both work. I'm going to go with the rate error saturation throughout the. So these are just some examples. On the left-hand side, you see it's Instana dashboard, right, where we show the information of that service. But obviously, this is not bound to any tool whatsoever. And so here on the right-hand side, I've just introduced a Grafana dashboard that shows similar stats, right? And in OpenShift, you get similar views of showing the traffic, showing the errors, and red request errors and duration. All right. So the question is, if we're looking at this, is like how, okay, that's great. Like, let's look at these example and let's look at the data, but how do I get to this data? And there's many different ways of doing these. I guess the most common one, and at least out there in the space, that we're capturing these natively or with some library out of the workload itself. And in the OpenShift cloud namespace, Prometheus is the standard. And if we're looking at Java, again, there's tons of options of just using a specific library called client Java, JMX exporter, or micrometer exporter. So that's the most common one we're seeing, and also probably very straightforward. A different way of doing this is actually capturing this from distributed traces. So with distributed traces, something that Instana is built upon is that you look at the traces between the different services, and kind of use these traces to calculate the different KPIs. The advantage with that is that it's like you don't have to do anything. If you're looking, for example, if you're using a service mesh, or if you're using Instana, you don't have to do anything. You can capture them automatically. And the other one advantage is, at least with Instana, that you can dynamically change this. And Instana and other tools, you can dynamically change the service composition, the granularity, something that I talked earlier about. So that's an advantage of working with it. Just one note: if you are if you're sampling the traces, please be wary about this, and store the metrics separately. Actually, there's a good link that I found from a Red Hat colleague that just did this with Open Tracing and Jaeger to collect and store the application metrics in Kubernetes. But there's another example with OpenZipkin. All right, so we've got the logical service, and whatever we do, right, whatever we look at, that's always the starting point. That's where we are basing our SLIs on, our service level indicators, our SLOs, the objectives that we strive for, and it's just the kind of the starting point to it all. And if you do one thing, then do this, right? But I think for understanding the whole perspective, for understanding everything, I think the other perspectives are equally important. Which brings us to Kubernetes. So Kubernetes, as the don't need to talk about that too much for this audience, but the orchestrator of distributed workloads has a lot of new things to take care of that might have been hidden earlier, right? Kubernetes opens up this environment for us and schedules the workloads across the fleet, and makes the resources available to the Kubernetes, to the resource available to the actual workload, right? Something that I haven't included in the example earlier, persistent volumes to the Elasticsearch environment. So to the Elasticsearch application. So actually, the database can be stored. So that's the job of Kubernetes, and has these great APIs everyone is talking about, and makes sure that the different setups are or different workloads, new workloads with operators, existing workloads with existing schemes, are distributed throughout the system, and that the cluster has the knowledge of how to work with this in the beginning and throughout the life cycle. Now, the question is now, what do I need to look at again? So I guess the first one is it's just the cluster itself, right? Depending on where you are, if someone else is managing it, you probably need to look at the cluster itself as on the control plane, just making sure the cluster itself runs. And if there's a problem, that you again can correlate something with this, right? Is etcd behaving as expected? Is it kind of distribute the knowledge through the etcd? That is just one indicator or one information that you need to gather. Now, on the workloads itself, the distribution state is essential. Like, how many of my desired workloads pods are running, right? If it's a daemon set, is it evenly distributed on all the nodes that I want to have taken care of? And if I have a deployment, is it at the scale that I need? And if something is going unavailable, is that still in my budget, or is that something that I need to consider? On the workload side of things, for the scheduler to run, for making sure that the workload is distributed, we have requests and limits. So we need to put these in consideration in context to the others to make sure that we've got that covered. All right, again, 2 examples here. Looking at the different CPU resources of the requests and limits and how the utilization of these are is something, if you're looking at from the Kubernetes perspective, the starting point of investing things. And maybe a little bit on the starting point, that's also something that I found very interesting. These 3 perspectives is in no means is there a we need to measure the services, as I said earlier, but it's not something that it's also very natural for people coming from a different background starting somewhere else, right? So with a Kubernetes environment, maybe I'm more on the DevOps side and need to level up, need to make sure that a new namespace is running smoothly, right? So I'll start with a namespace. But I guess the important piece is that when you start in Kubernetes, that you also understand how is it running on the host itself, on the cluster itself, that you have some means of getting there, and that you also have some means of understanding what the applications, what are actually the developers putting on there, right? So having good starting points, I think it's important, and linking them again, which I'll talk about. How to measure, that's actually pretty nice in Kubernetes, right? Because it basically is all there, right? We've got kube state metrics, which talks about all the things around the workloads, the configuration, its service itself, and just provides these metrics. On the control plane, we have the individual metrics endpoints. And for completeness, there's metric server to do auto scaling. So everything is already there. And have the dashboard there, but with these being provided as standard, there's also like a lot of pre-canned dashboards ready to just have this perspective ready and easy to see. And we have that in Grafana, we have that in OpenShift, so it's pretty easy to get started with and to enhance with more metrics. All right. Infrastructure. So why do we then now need to look at infrastructure? And the example that I gave should hint at it. Right? The I/O problem on the host is something that is needed for the troubleshooting. But also without the troubleshooting, I think it's something that we shouldn't be afraid of, or developers, DevOps shouldn't be afraid of having this in mind. And not like only look at at my pod and my JVM, but also understanding of how the JVM runs. What are the threads doing? How is it running on the host, right? Maybe that's one takeaway for this talk, right? Is encouraging developers to look into this and understanding of what's happening there. Hopefully, maybe with this talk, a little bit of what to look at. Now, very, very important, right? We talked about the services being the starting point. That's still the case, right? CPU utilization, as Adrian Cockcroft says, is virtually useless as a metric in itself. There are so many assumptions in there that if you just look at the CPU utilization and try to learn on it, you will most likely be wrong. But putting that in context and understanding what the service impact is to a possible problem on the host is the point I'm trying to get at. There's a great method similar to the RED method. There's a similar method here by Brandon Gregg, an awesome performance engineer, does lots of talks and lots of great books. And the use measures talks about, for all physical server components, so we're looking at CPUs, memories, and storage. For all of these, look at basically 3 things. First of all, look at the errors, right? If there's an easy way to get at the errors, look at the errors and what do they tell you. Look at the utilization, so how busy the resource was serving the work, and the saturation, so how much work is kind of like queued up for this resource to work at. So on the host level, we have all, these gazillion resources on the host itself or connected to the host. So, something that, probably everyone should, have a look at is the CPU and memory on the usage side of things, on the load side of things. And again, dashboards are all over the place. I guess it's just, it's important, getting familiar with it. This is another example. I just found that interesting on the JVM side, right? JVM being such an important part of our system is that we kind of looking into it deeper and looking at different metrics there, be it threads, be it the heap, the memory pools, and especially the garbage collection, is something to understand and have ready when you're looking at problems. So again, we've got the infrastructure metrics. So how would I get there? In Kubernetes, the best way is actually to work with some exporters. So there's the node exporter and the JMX exporter. Also, CAdvisor is promoting a couple of good metrics on the infrastructure side of things. But it's important that for some performance reason, you need to also look at the instrumentation itself. That for some performance reason, more native instrumentation might be needed. Our sensor, and that's true for other sensors probably likely also, is that we're doing more or less roughly 50% of the instrumentation we're getting out of in a native way, just to be more performant. All right, so we've got the service, Kubernetes, and the infrastructure, and they're all needed, and I guess to be taken care of in itself. Now, what do we do with the context? How do we stitch these things together? And that's something that we within Instana, we've basically built our tool upon, but it's something that you can also do yourself. When I was preparing the talk, I actually realized that there's a pretty good standard in the upcoming that hints at a lot of these, and that's the OpenTelemetry. So there's lots of things in the OpenTelemetry, but something that for this context I would like to highlight is the resource semantic conventions. So the resource semantics conventions in OpenTelemetry, they describe how a resource should be considered of in a consistent manner. So there's a couple of kind of tagging suggestions, and in OpenTelemetry there are not only suggestions, but there's also some mandatory required ones and some optional ones. But I think that's a pretty decent, pretty good starting point if we are thinking about how to correlate these together. So if you are working with if you've got a service and you picked like a service name, and OpenTelemetry talks about a service namespace that make these things unique together, and then you correlate it to a service instance ID, so something that serves this service, then you've got an unique identifier of what this thing is that actually serves this, right? Again, in Instana, we also have the service type, but which I think makes a certain use cases easier and easier to get at, but OpenTelemetry does not know this. Now, so we've got the service, right? And if we're using this tagging theme, then we can start correlating things together. We can see, okay, this service belongs to this container, to this host, to this Kubernetes pod, for example. And the other way also around, right? The information that we've gathered from all these different other instances are common tagging schemes that we can use to excuse me, that we can use to correlate one to the other. Now, A different way of looking this is if we're looking at the trace world of things, and I'm mentioning this explicitly because, as I said earlier, the service metrics that we gather are based out of traces. So we infer a lot of these, we and others, right? It's not unique to Instana, but those who are working that way infer a lot of these information out of it. And the interesting or the way to look at it is if you've got traces, right, that you use the trace ID in itself to correlate things. Here's the first one. The example is from Grafana, and they talk about how to use the trace ID in logs and use a common service tag throughout the system. Something that this service name here they're using slightly different, but throughout the system, so that they can then look to the service. Something interesting that I found with Luebken traces that the tag spans had the pod ID, and for the service naming, they were looking at doing a reverse lookup on the pod ID and then enrich the pod data. The OpenTelemetry talks about making this more and more automatic, right? In an open standard, we already do this as do others. So this is an example, and I mean, we could also do a short demo if you like, but this is an example of how we are doing this and how this is visualized in Instana. So this is our example, but basically we separate these three different perspectives: this application perspectives, Kubernetes application, and infrastructure perspectives, and basically on any entity that you're looking at, you can link to the others. But conceptually, it's not. You can rebuild this with your own tools, or again, just give it a try with Instana. So key takeaways, if you like, we've got service, Kubernetes, and infra. Please consider all of them. Please also consider them all of them independent and make the best use of when you're looking at these independently, because there's always someone coming from that particular background, and if you overload them with information from different perspectives, they might be overwhelmed, right? These different perspectives, share them, right? Make them shareable within the team to ensure a common understanding of what to measure and why you measure them. Why is this particular saturation metric for your workload the most important one? Last but not least, right? Context is king. Link these together, make them aware for everyone, and link them together so everyone has the same understanding of what you can do. All right. I guess this is it, at least for what I've prepared. And I think we've got time for questions. I'm going to stop sharing here.
Well, keep sharing just for a minute.
Sure.
I would love you to do, and Michael managed to get internet, so that's it. But what I would love you to do is if you could go over to the Instana site and go to the install the operator page, just so people have that link too, because I think that would be great, and that would get them, at least to know where you live and breathe in Instana as well, and where all the docs are as well. You can also go to the Red Hat catalog and grab it from there.
Right. Yeah. So maybe a couple of words. Can you see my screen?
I can indeed.
All right. So a couple of words to the operator. The Instana operator is actually, so we've been really been stoked about the operator and IO, right? Right. So the Instana operator is actually basically available wherever you like, right? It's obviously installed in the operator hub. You can also get it in directly. We've included it in our environments on how to install the agent, or you can just get the source and get everything from GitHub directly. Now, the operator or the agent operator does a lot of like nice things for us, and it helps us distributing of what we do with our agents. So if we're going back to the talk that I talked about of correlating all these different things together, that's something that the operator, the agent does. And as you can think of, if we're taking this the next steps further, we've got infrastructure, Kubernetes, and services, but you've got all mixed in with all the cloud stuff, with different operating environments, with different runtimes. So there's lots and lots of things to do, and the operator helps us on distributing that workload throughout the cluster, and just picking or selecting different nodes, putting some intelligence to our operator, and making the operator making the agents very dynamic and in what they do. The operator itself is on the agent side, and we've got something cooking on the backend side, but that's for someone else to share at a later point.
Well, Michael Waite did manage to get some internet, and he just put the link to the catalog, the Red Hat catalog software operators for your operator in there. So I'm not sure, we're seeing your slides right now, we're not seeing your browser. So if you want to pop over there, and Michael has a few questions.
Oh, I'm sorry. So we're talking about Operator Hub. I apologize.
Well, that's okay. So a little context is king here. OperatorHub.io runs all of the open source, runs anywhere on any Kubernetes, and then explaining maybe a little bit, Michael, what the catalog.redhat.com operators are, what that's all about.
Yeah, sure. And I'm so sorry that I'm late. I have no control over this, but I've been working from my cabin in the mountains for the last 7 months, and it's like it's a DSL phone line running through the woods. So when a moose gets crazy, things can go down. So I apologize for being so late. But I did link the and hi, Matthias, how are you? It's nice to see
Doing great.
Nice to see you wearing an Instana name badge these days. Got a question for you on that, but
sure.
No, I did link the Red Hat catalog because our team works with companies like Instana and others to run their operators through the Red Hat certification process, which really allows customers to know that all the parts and the internals of it are like the Blueberry Pillsbury Muffin Man seal of approval, that the Red Hat components and the Instana components are all supportable and they can use it in a production environment. So that's where our customers can go to download something and make sure that they're getting genuine Intel inside parts. So that's
Am I sharing the right screen now?
Absolutely.
Yeah. Yep.
Yeah.
Yep.
Yeah, and again, the operator. So you can think of the operator in multiple dimensions. So far we don't have in our tool dedicated supports of monitoring operators. So it's just used as a custom resource definition. But obviously, as it gets more and more used by developers, it would be one of the additional perspectives. Okay, we've got the services, we've got Kubernetes, we've got infrastructure. So looking a deeper or more intelligent look at the Kubernetes and Kubernetes layer, the operator gives means of even better understanding and better linking these together and putting some semantics into the operations of let's take the Elasticsearch for example, right? And that's totally in a layer that I can think of adding. We are running our operator with great success, and are thinking greatly about how to leverage the knowledge in an OpenShift or any Kubernetes cluster.
And this doesn't just happen by chance. I actually was at a trade show. I think it was probably one of the early KubeCon ones. I think it might have been in Seattle or Portland, I forget where. And I ran into one of your founders. His name was Pete Abrams. Pete Abrams, terrific guy. And I was talking to him about what we were doing, and And Instana was probably one of the first APM type vendors that ever certified a container for the Red Hat portfolio and built an operator. And that was because we were working with them very closely. And I used to travel down. Pete invited me to your sales kickoff in Miami. It was probably 2 or 3 years ago now. And so me and my team flew down there. We bought, appetizers and drinks for the entire sales organization at Instana. So we've actually had a really, really good, close working relationship with your whole team, including your marketing people as well, for a number of years. So this doesn't just happen by accident, and we're doing these types of things together to make the overall customer experience as good as it possibly can be in a cloud native environment.
And we continue to do so, right? So this is on the agent side, but we also have lots of backend components. So I'm not. It's again for another conversation down the road. I need to get my colleague online for this, but we're going to continue investing in there.
That's cool. So, hey, I don't see any other questions coming in about your technology. If anyone else on the, go ahead, Diane.
There is one question. Someone is asking about the backend operator status that you referred to sort of and said someone else would. Can you give us any hints on when that?
No, I can't give any hints. I apologize, Chris. I apologize. Maybe I should have even mentioned it. Apologize.
Now, is that when you say the backend operator, you're talking about that right now there's an Instana agent which is containerized and certified, and then are you talking about Instana, the actual the smarts on the back end actually being turned into an operator as well?
Exactly. So Instana itself, so obviously you need to have the agent running, but we have an on-prem solution or a self-hosted solution as we like, and Kubernetes always has been, or for a very long time, been our primary way of surfacing this, and with operators with our experiences on the agent side, we're also looking into what we can do on the backend side to make the on-prem install easier and faster.
Okay, and is that being driven by customers because they're saying, we have certain requirements where we need to have the full APM solution inside our infrastructure from a security perspective or something like that?
Right. So the traditional on-prem questions apply here, right? So making sure that it's secure, that it's in-house, but also performance reasons of ensuring that it's nearby the actual workloads. So there's a multiple way of reasoning about or motivating this. We don't take a stance right there. We just try to make it as easy as possible, and operators and a homogeneous environment like Kubernetes or OpenShift gives us the means of installing it.
Yeah. Hey, we got another question. I don't know if you can. I'm gonna read it here, and maybe you can translate for me, Matthias. But
right.
So Jeffrey says, hey, in New Relic, as we're using right now, we have the AppDex, which measures satisfaction or response time based against a set threshold to get the insight of the application health. Does it have any corresponding features for Instana?
Right. So AppDex is a really, really important and aspect of monitoring your applications. Something that we are more leaning towards is the SLI SLO way of looking at this. So we've just introduced that that you define service level indicators on your customer journeys, define these and alert on these. And also with our application perspectives, there's you have much more fine granular control of which traffic, of which aspect you're looking at, and alert on these. So right now we don't have the very, very same equivalent to what AppDex is. But I think if you look at Instana of what we provide, I think at the end you will also be possibly even more liking the way we translate these things.
Okay. Hopefully, Jeffrey, that addresses your question. If it doesn't, I'm pretty sure that we can get you just about any questions you want. Where would we send people to if they have follow-up questions? I mean, my email address is wait@redhat.com. It's just WAITE@redhat.com, and I can connect people with just about anyone at any level of the organization in Instana. I am from top to bottom very close with everyone over there. Matthias, do you have? There you go. There's your email address as well.
There's my email address, instana.com. There's a gazillion ways to reach out. Whatever, ping anyone at Instana, and we'll get back to you. And Jeffrey, if you would like to talk about more about the AppDex standards, I'm happy to go into some detail with you, and especially looking at use cases, like why are you looking at the specific one? That's very important to us, is understanding why this particular measure is important and helps you there. And I think we usually got a good answer on that.
Hey, Matthias, I really wanted to ask you this at the very beginning, but as I said, I've been dealing with legacy internet issues.
Next time I'm coming to the cabin, and I'm gonna hang out in the cabin earlier.
You want to see what it looks like real quick? I mean, this is
We're all going to the cabin soon.
Awesome.
This is my front desk right here.
Oh, nice.
Oh my God, yeah.
Yeah, this is.
But I was gonna ask you, Matthias, you were at Red Hat for several years, and then you moved to Instana. How lucky are you? I mean, I think that being able to be a part of that team in this time where everyone needs APM for helping them to have the visibility and insight into running their business in the hybrid cloud. Are you just absolutely thrilled to be there? Or I know I was.
Well, first of all, I was thrilled also to be at Red Hat. Red Hat was really a great time, and we built some nice, really awesome tools. I was more on the developer side of things there, and in the code ready. And we really built an awesome tool for analyzing dependencies. So shout out to all my ex-colleagues. That was an awesome, tremendous time. And yes, obviously, Instana is great because we kind of are challenged in a new way of being going against other players in the market, but using this new microservice movement to our advantage and build, I think, something very unique that is just very suited to this new environment. Just one example, I think, which is also very dear to my heart, is that it's really, really easy to get started. Our agent discovers everything, throws everything on the dashboard, and yes, you need to tweak and configure things, but everything is just there, right? It's there. As we're talking about different perspectives of what people are looking at, I think for myself, but I also hear that from customers. It's just great that you've got a platform that you look at, and then you've seen the majority of things already there, and then you can kind of then dive into details and start tweaking. But you're not lost at the beginning, and that's something that I value within Instana a lot about. And the whole distributed tracing is just a fun topic. It's just a fun technology.
Cool. Well, I don't see we have any more questions coming in, and I know Chris Short is going to let us know that we're just about out of time. So I thank you so much for coming on. I mean, I reached out to Star, who's my marketing contact over there, and I was like, you got to find me someone like really, really good to be a part of this. It's our one of our early on OpenShift Commons briefings, and so we're really, really glad that you guys could help be a part of this today.
Glad. Thank you very much for the invitation. Always a pleasure. Happy to come back. And it's yeah, it's some great technologies mixing in together. And yeah, happy to be here.
All right. And when you get that back end operator and you're ready to talk about it.
I'm gonna let my colleague know, and we're gonna talk. Yep.
All right. Take care, all.